Hi everyone, this is Mrs. Musoff here, and today we are going to talk a little bit about slope. Alright, so we're going to talk about how to find slope graphically, so that means if you're given a graph, how to find it algebraically, which would be if you're given like points, and then using tables. And we're also going to throw in some x and y intercepts too. So a lot of little graphing pieces that are going to help us to understand what graphs should look like, how to draw them, that kind of thing. Alright, so let's start with slope. Slope has two names. You can call it slope, or sometimes you'll see places call it the rate of change. And that's because it tells you the change in y versus the change in x. Alright, so it's a rate of change. Now there are a bunch of definitions for slope. The one we use graphing is the rise over run. So the top number tells you how much to go up or down, and the bottom number tells you how much to go left or right. This right here, that's the algebraic definition. So if you're ever given points, we use that definition in order to find the slope. Alright, later we call it m, so if you ever see that variable in a formula, that's usually going to represent our slope. Okay, when it comes to slopes, a slope is just a number, but there are four different types of numbers that you could have as a slope. You could have a negative slope. Now, if you have a negative slope, again, think about how we read books left to right. We read graphs the same way. So if you have a negative slope, that means you're going to have a line that's going down left to right. Alright, think of it as if a person were to walk that line, they'd be going down. They'd be falling. That's a negative. Alright, negative slope means the slope is falling. Alright, if your slope is equal to 0, that's going to be a line where, try to imagine if a person was walking, they wouldn't be going up or down, they'd just be staying at the same level. Alright, so that's a horizontal line. Just like this, right? If somebody were on that horizontal line, they'd just be walking along, no up, no down, just level. So that's a 0 slope, right? Nothing's really happening. Okay, so 0 slopes, horizontal lines. A positive slope, again, think left to right, means you're going to be traveling up. Alright, so if somebody was walking along this line, left to right, they'd be going up. That's positive because the slope is rising. Alright, the last one is an undefined slope. That's the trickiest one because there are some lines that have an undefined slope. The way I like to think of it is think of a line that you can't possibly walk. And maybe this is hard to imagine, but a vertical line. Alright, if I were to try to walk a vertical line, what would happen? I would immediately fall down or fall off of the line because you can't walk a vertical line. So that's how you know it's undefined. So undefined slopes mean that line is going to be vertical. Alright, you can refer back to this if you ever need to, just to remind yourself. Now, let's try finding the slope. So it says find the rate of change of the line passing through the points. Remember, rate of change, that just means slope. And I mentioned earlier that when you're given points, we have a formula we're going to use. Slope, m, is equal to y, let's use the same one we have up top here. So y1 minus y2 divided by x1 minus x2. Okay, these x's and y's and things, those are just the points. So you'll have one point labeled x1, y1, and one point labeled x2, y2. And that's how you'll know where to put things in the formula. So for example, if we try number 1, I have 2 points, negative 3, 0, and negative 1, 6. So that first point I'm going to call x1 and y1. My second point I'm going to call x2 and y2. And then I'll just plug them in where they go. So my slope m is equal to, this says y1 minus y2, so that's 0 minus 6, divided by x1 minus x2, so negative 3 minus a negative 1. And then I'll just simplify. 0 minus 6, that's negative 6. Remember, a negative and a negative here, that's going to turn into a positive, plus. So negative 3 plus 1 is negative 2. And then divide. Negative 6 divided by negative 2. My negatives cancel out. 6 divided by 2 is 3. So my slope is 3. Now notice how that's a positive slope. Because it's positive, that means it is a line that's rising. So you should imagine a line that's going up left to right. Okay, let's try it again. Number 2, again, 2 points, 2, 7 to negative 15. So my first one is x1, y1. My second one is x2, y2. Now, does it matter which one's 0.1 and which one's 0.2? Not at all. You can switch it around. It'll still work in the equation. Alright, so slope is y1 minus y2, 7 minus negative 15. Divided by x1 minus x2, that's 2 minus 2. Okay, minus a negative here. It's going to turn into a positive, a plus. 7 plus 15 is 22. And then what's 2 minus 2? You got it. 0. Well, this poses kind of a problem. Because, you know, in math, there's one thing you are never allowed to do. And that's divide by 0. We can't divide by 0. It is not allowed. Who knows what might happen if we try. So if you ever see that you're dividing by 0, this kind of number, we call it undefined. So in this case, this would be an undefined slope, whenever 0 is in the bottom. If 0 was in the top, that's completely different. You can have 0 in the top. That whole fraction would just equal 0 then. Alright, it's only when 0 is in the bottom that you have an undefined slope. You remember what kind of line would have an undefined slope? No? Well, just take a look right up here. Undefined slope, that's a vertical line. Alright, so just so you have a picture in your head what it's going to look like. Alright, let's say you were given a graph and asked to find the slope. The graphical definition for slope is going to be rise over run. So all I'm going to do is I'm going to start with the point on the left, and I'm going to count how much I have to go either up or down. Just remember, up means it's a positive number, down means it's a negative number. So to get from this point to this point, I have to go down 1, 2. It looks like that's it. So because it's down 2, that's like a negative 2. And that's going to be my rise. My rise is negative 2. Okay, then I count how much I'm going left or right, and that's my run. Left is negative, right is positive. So this is to the right, 1, 2, 3, 4, 5, 6. So that would be a positive 6. And again, that's going to be my run. So to calculate my slope, I'm going to go rise over run. That's negative 2 over 6. Negative 2 divided by 6. And then this is one of those fractions that you can reduce. I just have to divide by 2 here. So we end up with negative 1 divided by 3. And that's our slope. Alright, so graphically it's mostly just counting. You just have to remember the definition. And that's this right here. Alright, as long as you know that definition, you should be good to go. So for example, in number 4, once again I'm going to count the rise and then count the run. So if I start at the point on the left, how much do I have to go up or down to get to the point on the right? I hope you said nothing, because you'd be right. I don't have to go up or down at all, right? It's straight across from it. That means my rise is going to be 0, because I didn't go up or down at all. Alright, my run is 1, 2, 3, 4, 5. Positive 5, because I went to the right. So that means my slope is going to be 0 divided by positive 5. Well, like I said earlier, maybe you forgot, that's okay, I'm here to remind you. When 0's on the top, when 0's on the top, that's just going to equal 0. Alright, so my slope here is 0. Notice how it is a horizontal line. That's what we said happens when you have a horizontal line. We said you have a 0 slope. So these kinds of things should connect. Alright, go ahead and flip the page over. Last piece of slope. Finding the rate of change, again that's slope, when you're given a table. Well, remember, a table is just a set of points. So we can find the slope with a table the same way we find it with a set of points. And that's using the definition. y1 minus y2 divided by x1 minus x2. I should say using the formula. There are a lot of definitions. Great. The only thing you have to do is pick a couple points. So anytime I see negatives, I get kind of worried I'm going to mess up. So I'm going to pick 2 points that aren't negatives. Let's try these 2. I'm going to call this first point x1, y1, and my second point x2, y2. And then I'll plug it in. So I'll do y1 minus y2, that's 4 minus 16. x1 minus x2 is 6 minus 10. 4 minus 16. Feel free to use those calculators if you need to. Alright, I know sometimes these can get tricky. I'd rather you make sure you get it right. So 4 minus 16 is negative 12. 6 minus 10 is negative 4. Negatives cancel out, and 12 divided by 4 is 3. So there's our slope. Alright, now in number 6, notice how we got all negatives in the y side. Can't always avoid the negatives. So I'm just going to pick my smaller numbers here to work with. Alright, again, I'm going to label one pair x1, y1, 1x1y, x1, y1, and then the other one x2, y2. And then we'll plug it in. y1 minus y2. Be careful with these negatives. It's negative 6 minus a negative 9. And then over here, it's 2 minus 2. Alright, now before you go through and do the top part, take a look at that bottom. Do you notice what's going to happen? A positive 2 and a negative 2? That's going to turn into a 0 on the bottom. Do you remember earlier what we said it means when there's a 0 in the denominator? It means you're dividing by 0, which is a no-no. So that means you are going to have an undefined slope. So when you see 0 on the bottom, again, think bad, think undefined. Alright, last piece. Another important part of graphs are the x and y intercepts. Okay, x-intercepts are always on the x-axis, y-intercepts on the y-axis. Makes sense, they go with each other's letters. And then we always write these points as an ordered pair. That means x comma y with parentheses around them. So for example, in this picture, if I were to write the x-intercept, that would be right here. Alright, the x is negative 5, so I would start with the negative 5. And the y, since I'm not going up or down at all, is 0. Same kind of thing for the y-intercept, except here I'm not going left or right at all, so my x is going to be 0. And the y, well, it's kind of right in between 1 and 2, it looks like. So I'm going to call that 1.5. Okay. So let's take a look at a couple graphs. Let's make sure this makes sense. Our x-intercept, again, remember this is our x-axis, the horizontal one. So for the x-intercept, we're looking at the point where our graph touches the x-axis. Looks like that's at the x value 3. So my x-intercept is going to be 3, 0. The y-intercept is where your graph touches the y-axis. Do you see this graph touching the y-axis at all? No, it's going straight up and down. That means there's no y-intercept, so I would just write none. Alright, it is possible to not have a y-intercept. Same kind of thing with number 9. So again, x-intercept, I'm looking at the x-axis. I find my point, that looks like it's at 1, so that's 1, 0. And then for my y-intercept, we got the y-axis. That's right down here. It looks like it's at negative 2, so that's 0, negative 2. You can always tell where to put the number, because if it's a y-intercept, the number should be in the y spot. If it's an x-intercept, the number should be in the x spot. Alright, that's all from me for today. If you have questions, make sure you ask your teacher or stop by the resource room and I'm sure somebody can help you out. See you later.